Welcome to The Explainer. Today, we are going to pull back the curtain on an invisible force that, well, it powers your phone, it makes lightning crackle across the sky, and it literally holds the very atoms of your body together. We're talking about electric charge. And it all starts with something you've probably done 1,000 times, a little party trick. You take a balloon, you rub it on your hair, and then you bring it over to a wall, and boom, it just sticks, right? No glue, no tape. So what in the world is going on here? You know, solving this one little puzzle is the key to understanding the fundamental rules that govern, well, almost everything. And to get there, we need to meet the main character's inner story. So in this invisible world of electricity, there are really only two kinds of players, two characters, if you will. We simply call them positive and negative. And their entire existence, everything they do, is built on a very, very simple set of rules. And this is the golden rule. It's the one law that governs every single one of their interactions. Positive charges are always drawn to negative charges, but two positives, they'll push each other away. Same with two negatives, always. And this shows you exactly what I mean. See on the left, that negative rod is being pulled right toward the positive one. That's attraction. But on the right, those two negative rods are actively pushing each other apart. That's repulsion. It's simple, but it is so, so powerful. Okay, so we've got the main rule down. Opposites attract, likes repel. Now, let's add two more crucial principles to our investigation. And these aren't just suggestions, okay? These are unbreakable laws of the universe. First up is the law of conservation of charge. Now, before you do anything, most objects are just electrically neutral. They've got a perfect balance of positive and negative charges, just like this glass rod and silk cloth here. But when you rub them together, you're not creating new charge out of nothing. You're just moving it around. These little negative charges, the electrons, they literally jump from the glass over to the silk. So the big takeaway here is that charge is always conserved. The total amount in the system never, ever changes. All right, our second clue is that charge is what we call quantized. It's a bit of a sciencey word, but all it really means is that charge comes in these tiny individual packets. You can have one electron or two or a billion, but you can never, ever have half an electron. It just doesn't work that way. The smallest possible packet of charge has a name, the elementary charge. Now, of course, these charges don't just exist in a void, so the next piece of our puzzle is figuring out how they move around. And it turns out not all materials treat charge the same way at all. Some materials, which we call conductors, are like these wide-open, multi-lane superhighways, letting those little electron charges zoom around freely. But others, we call those insulators, they're more like dead-end streets, where the charges are pretty much stuck in place. You see this all the time. Metals like copper and silver are amazing conductors. That's why all our electrical wires are made of them. But materials like glass and rubber, total insulators. They hold on to their electrons for dear life, which is, why an electrician wears rubber gloves. And this difference is absolutely the key to solving our balloon mystery. Okay, we now have all our clues. We know that opposites attract. We know that charge is conserved and comes in packets. And we know that it moves differently through conductors and insulators. With all that, we can finally crack the case. So check this out. It's a process called induction. If you bring a negatively charged rod near a neutral sphere, one that conducts electricity, all the free electrons inside that sphere are repelled. They run to the other side to get away. Now, if you give them an escape route, like a wire connected to the ground, they'll actually leave the sphere entirely. This leaves the sphere with a net positive charge. And get this, you've charged it without ever even touching it. And that is exactly what's happening with our balloon. The wall is an insulator, remember, so its charges can't really leave. But when that negatively charged balloon gets close, it pushes the negative parts of the wall's molecules away and attracts the positive parts. This creates a temporary little patch of positive charge right there on the wall surface. And since opposites attract, the balloon sticks. Mystery solved. So we know how it all works, but that just opens the door to an even bigger question. Just how powerful is this incredible invisible force really? I mean, sure, it's strong enough to hold a party balloon to a wall, but what's its true power? Can we actually put a number on the strength of this attraction and repulsion? Well, thanks to a physicist named Charles Coulomb, we absolutely can. He figured out the formula, we call it Coulomb's law, and it basically tells us two things. The force gets stronger if you have more charge, and it gets way stronger as you bring those charges closer together. But here is where things get truly mind-blowing. Let's take that law and apply it to the absolute smallest scale we can imagine, the building blocks of matter itself. Let's look inside a single, simple hydrogen atom with its one positive proton and one negative electron. Okay, you ready? Inside that one tiny atom, the electric force that's pulling the electron and proton together is about this much stronger than the force of gravity pulling them together. That's a 2 with 39 zeros after it. I mean, just look at that number.
It is a number so big, it's almost meaningless. The force that holds atoms together, the force behind all of chemistry, all of biology, pretty much everything you see around you, is astronomically more powerful than the gravity that pins us to the Earth.
I mean, think about that for a second. We feel gravity every single day, right? But it's this hidden, vastly more powerful electrical force that is truly constructing our world from the atom up. It really makes you wonder, what other powerful, invisible forces are shaping our universe right here, right in front of our eyes?